Hello and welcome to another NGen Math 8 lesson by eMath Instruction. My name is Kirk Weiler, and today we'll be doing Unit 12cc, Lesson 4 on Categorical Data. All right, now let's get right into it and discuss a little bit about categorical data. In statistics, we often collect data that is categorical, right? There's two types of data in statistics. There's numerical data. That's typically data that you measure, right? How high do the plants grow? How much weight loss does this experimental treatment result in? Things like that. But we also get data that is categorical. And in other words, we simply put members of our population or sample, more likely, into categories. And we do this to see if there's some kind of an association between categories. So like, is it more likely if you fall in this category that you'll also fall into this particular category? This is very important in areas like marketing, areas like health research and things like that. Does falling into particular categories, if you fall into the category of 40 and older versus younger than 40, are you more likely to also fall into the category of being overweight, something like that? The answer is likely yes. So anyway, let's take a look at categorical data. Exercise number 1. Daniela is trying to determine if there's any association between how students get to school and whether or not the students buy lunch or bring lunch from home. She does a survey and partially fills out the following frequency table. All right, so a frequency table is just a table that shows you the results and how things are broken down into categories. So the first thing we want to make sure is that you understand how to simply read one of these tables. Let's take a look at letter A. How many people rode the bus and bring their lunch? All right, so how many people rode the bus and bring their lunch? Take a look and answer this question. All right, well, it's pretty simple, right? These four numbers basically break down all the people that were in the survey into really kind of four different categories, right? And the category we're looking at is people who rode the bus and bring their lunch. So that would specifically be these 12 people. Again, just making sure that we know how to read this. By the way, there were 9 people that bring their lunch and walk to school. There's 7 people that buy their lunch and walk to school, and there's 22 people that buy their lunch and ride the bus, right? That's kind of the way that we read these tables. Now, letter B is pretty simple. Fill in the table by filling in the missing total blanks. All right, so in other words, sometimes these frequency tables, as we call them, have totals given, sometimes they don't. But by totals, all I'm trying to do is I'm trying to figure out the total number of people who walk to school. And the way I do that is I count up the number of people who walk to school that buy their lunch and the number of people who walk to school that bring their lunch. And when I add the 7 and the 9 together, I find that a total of 16 people walk to school. All right, see if you can fill in all the remainder of the blanks in that frequency table. All right, so let's count up all the people that rode the bus. That'll be these 22 people and those 12 people. So when I add them together, I find that there are 34 people that ride the bus. I can now think about how many total people buy their lunch. There are 7 people who buy their lunch that walk and 22 people who buy their lunch that ride the bus. So if I add these up, I can get 29. And likewise, people who bring their lunch, I can add those up and get 21. Now, the final little blank, and this is an important one, is when I add up all the people who walk and people who rode the bus, right, I'll find that there were 50 total people. And that total will be the same as when I add up all the people who buy their lunch and all the people that bring their lunch, 29 and 21, also gives me 50. All right, that number right down there is very important. It shows us the total number of people that were in this survey, that were questioned about whether they buy or bring and whether they rode or walked. Okay, now, Now, although frequency tables are important, What is more important are what are called relative frequency tables. So let's talk about those in exercise 2. Daniela would like a relative frequency table for her data. Fill in the table below with all relative frequencies by dividing each entry in the original table by the total. You will not need to round any of your relative frequencies. All right, so a relative frequency, okay, is sort of showing us how many people in the survey fall into a particular category relative to the total number of people. And we do that with fractions / division / decimals. Okay, and here's how we do it, right? If I go back up to the original table, come on, what I see is that there's 7 right here. So what I'm going to do is I'm going to take each one of these things and divide them by the number 50. Literally every number I'm going to divide by the number 50. So for instance, right, I can take 7 and divide it by 50. And if I need to use my calculator on this, I certainly should feel comfortable with it. You know, I'll just do 7 divided by 50. It's easy enough to convert that to a decimal without your calculator, but I have 0.14. Most of the time, if we have to round, which we won't in this particular table, but if we have to round, almost always relative frequencies are rounded to the nearest hundredth, And we'll kind of talk about why that is in a little bit, but our relative frequency there is 0.14. What I'd like you to do is now take each one of those numbers in the table, every single one of them, and divide by the number 50. Using your calculator or not using your calculator, it's up to you. All right, so pause the video now and fill out the rest of this relative frequency table. All right, so division by 50 is really quite nice because there's a nice pattern. So for instance, when I do 22 divided by 50, I will find that that is 0.44. I'm going to try to keep these all on there. 9 divided by 50 is 0.18. Maybe go up to full screen. That might help a little bit. Or maybe it won't. 12 divided by 50 is 0.24. I really want to divide everything by 50. So 16 divided by 50 is 0.32. 34 divided by 50 is 0.68. 29 divided by 50 is 0.58. The zeros on all of those aren't that important. 21 divided by 50 is 0.42. And 50 divided by 50 is equal to 1, but I'm going to actually write it as 1.00. You might notice in a relative frequency table, just like in a frequency table, they add. So 0.14 and 0.44 is 0.58. 0.18 plus 0.24 is 0.42. 0.32 plus 0.68 is 1.00. And they also add across as well. Now remember, in every one of these cases, what I'm doing is I'm simply taking the original number and dividing by the total. So I'm finding in decimal form the fraction or proportion of the total that falls into each one of these categories. Now there's an important thing though that we want to understand about this. And let's take a look at exercise 3 just to make sure that we have it. Relative frequencies are essentially the decimal version of what common math idea? So all of these things we could think of in a very related way, all right? What important mathematical idea are all of these getting at? Pause the video now and see if you can remember it. So these are all the decimal versions of percentages. These are all percentages, but the decimal form of them. All right, so these are the decimal form of percentages. And of course they are, right? Because something like 0.44 is 44 100ths, which is by definition 44%. Never forget that all a percent is something out of 100. And since all of these are rounded to the nearest hundredth, we can literally look at each one of them and go, oh, 0.18, that's 18 100ths, that's 18%. And so what it's really telling us, these relative frequency tables, is they are telling us the percent that each one of these occurs out of the total. All right? Make sure you have that by answering exercise number 4. In the survey, what percentage of the students A, take the bus and bring their lunch, and B, walk to school? All right, see if you can answer both of these, and then we'll go through them. All right, well, let's take a look. The first one is take the bus and bring their lunch. Well, if I take the bus and I bring the lunch, we're right here, 0.24, right? That is the decimal proportion, 0.24, and that corresponds then, bus and bring, to 24%. 24% of the respondents rode the bus and brought their lunch. Now, the other one, walk to school, well, that includes all the people that walk to school, and that has a relative proportion of 0.32, which is exactly the same as 32%. All right? And again, I mention that because for a lot of people, looking at the decimals, right, can be a little bit intimidating. It can be a little bit confusing, but what I really want you to think about is that you're really looking at percents, right? 14%, 44%, 58%, 18%, 24%, 42%, 32%, 68%, and 100%. Right? That last one is always 100%. 100% of people took this survey that took the survey. Right? Kind of the way you want to think about it. All right, so let's work a little bit more with this. Now, sometimes we want to know the relative frequencies just based on either row or column totals, and these are known as conditional relative frequencies. Oh, like if it wasn't bad enough, now we got to think about something a little bit different, but you'll get the hang of them. Let's take a look, exercise number 5. Find each of the following conditional relative frequencies. Give as both a decimal to the nearest hundredth and as a percentage. Okay, so now it could be a little bit more messy, but let's kind of take a look. Letter A. A person brings their lunch given that they walk. Okay, this is very important, this phrase. Given they walk. All right. As soon as you want a proportion based on some kind of a condition, this is the condition, that's why they're called conditional relative frequencies. I wouldn't be overly wrapped up in that term, okay? I'd be more wrapped up in this language. A person brings their lunch given they walk. And what that means is I don't want to think about any of the people that rode the bus. They are totally irrelevant in this problem, right? This is really almost a probability thing. A person brings the lunch given they walk. Well, how many people walked? 16. Of the people that walked, how many brought their lunch? 9. And therefore, the answer here in terms of a fraction is 9/16. Now, in terms of a proportion or a relative frequency, I can do 9 divided by 16. Whoops, that's 9 times 16, so let's try that again. 9 divided by 16. All right, that's sorry, I erased that pretty quick. 0.5625, okay. To the nearest hundredth, that's 0.56. So that is our proportion to the nearest hundredth, and that is also equivalent to 56%. Now, I want you to realize what we found here, right? What we found here is the fact that 56%, right? 56% of all the people that walked to school brought their lunch. That's all we found. We're not worried at all about the people who rode the bus. Let's take a look at letter B. A person buys their lunch given they ride the bus. All right? So again, here we only care about the people riding the bus. That's all we care about. So pause the video now and see if you can find the relative frequency that a person buys their lunch given that they ride the bus. All right, well in this case, 34 total people rode the bus. I don't care at all about the people that walked. And of those of those 34, the number of people that buy their lunch are 22. So 22 out of 34. Again, using my calculator. All right, 22 divided by 34 gives us 0.647, whoops, that should be a 4, 0.647, etc., rounded to the nearest hundredth, which we almost always do with these, is 0.65, and that is also 65%. All right, let me just minimize this real quick, right? So what we find again, we want to understand how to interpret this, is that if we looked at only the people that ride the bus, 65% of them then buy their lunch. All right. A conditional relative frequency is very similar to a relative frequency. The difference is, instead of dividing by the total, we're either going to be dividing by a row total, and sometimes, less likely, but sometimes dividing by a column total. Okay, let's keep working with this idea. Now, conditional relative frequencies, also known as relative proportions, are simply the fraction, or the proportion, or the percentage of a subgroup within the survey that has a particular characteristic. And you just have to be careful about the wording, that's all. So let's take a look at exercise number 6. A restaurant serves 2 types of juice for breakfast, orange and apple. They want to understand how the choice of drink depends on whether the customer is an adult or a child. During one breakfast, they record choices by age with the results shown below. All right, great. So we see this frequency table, right? So we know that, there were 26 adults that chose orange juice, there were 9 adults that chose apple juice. There were 28 children that chose orange juice and 19 children that chose apple juice. Simple enough. Letter A is an interesting question. How many people did the restaurant get data from? All right, well, pause the video now and see if you can figure out how many people the restaurant got data from. Okay, simple enough, right? We just need to add up all these numbers. 26 plus 28 plus 9 plus 19. Now I've lost my calculator. Gotta bring it back up. There it is. And simple enough, clear that out. 26 plus 28 plus 9 plus 19. All right, 82 people. Let me move my little calculator a bit out of the way. We'll keep it up on the screen. So there were 82 people, right? And it's important to note that we can always add up all of those numbers to figure out the total even when they don't have us have totals. Now let's kind of take a look at letter B. What proportion of all people surveyed preferred orange juice as their choice? Round to the nearest hundredth. All right, so what I'd like you to do is try this out, right? Now we're just looking at a proportion, so I just want that decimal version, no percents here. All right, don't get me wrong, the percent is very easily relatable to whatever the proportion is, but pause the video now and come up with the proportion to the nearest hundredth of all the people surveyed who preferred orange juice. All right, well, we've got to scroll back up, right? The first thing I need to know is just how many people preferred orange juice, right? So we had 26 adults and 28 adults that preferred orange juice. So we've got 26 plus 28, which is 54. Okay, 54 people preferred orange juice, and that was out of a total of 82 people. So there's our fraction, 54/82. All right, and now we're just going to do the division, 0.66, rounded to the nearest hundredth. So our proportion is 0.66. Now granted, right? I want to be able to look at that easily and say, well, 66% of all the people that were surveyed preferred orange juice. That makes sense, right? I'd rather probably have orange juice than apple juice in the morning, but there's our proportion. Now let's take a look at letter C. What proportion of all adults surveyed preferred orange juice as their choice? Round to the nearest hundredth. Okay, now this is a little bit different, right? Before I wanted the proportion of all the people surveyed who liked orange juice. Now I only want the proportion of all adults surveyed who preferred orange juice. So I don't care about the kids at all at this point, right? I just care about the adults. So pause the video and see if you can get this proportion. All right, so now I only want to think about the adults. I only care about this at this point. Now there are 35 total adults, and of those 35, 26 of them preferred orange juice. So my proportion is going to be 26 out of 35. And let me bring my calculator back up, clear this out, and I get 0.74. So again, thinking about this and talking about it in terms of percents, I find is quite helpful. 66% of all those surveyed preferred orange juice, but 74% of the adults preferred orange juice. So a greater percentage of adults preferred orange juice than the group as a whole, which probably means a smaller percent of the kids preferred the orange juice. But let's keep going. Letter D. What is the relative frequency of being an adult in this survey, given that the person preferred orange juice, round to the nearest hundredth? Now, this is a little bit different. Now I want the proportion of people who preferred orange juice who happen to be adults. Now I only care about the people who prefer orange juice, and I want to know what proportion of them were adults, right? The relative frequency of being an adult in this survey, given that the person preferred orange juice. This is an amazingly important phrase, given that they preferred orange juice. So pause the video now and see if you can answer this question. All right, well first we need to know the total number of people that preferred orange juice. Let me get rid of this, right? Now we care just about these people. That means, and we did that sum already, we've got 54 people that we're concerned with, and we want to look at those 26 people, right? So 26 out of 54, right? 26 of the people who preferred orange juice out of the 54, right, were adults. So clear that out, 26 divided by 54, and we find that 0.48, right? 48% of those people who preferred orange juice happen to be adults. That's the way that we can interpret that. 48% of those people who preferred orange juice happen to be adults. Let's do one more of these conditional relative frequencies, letter E. What is the relative frequency of liking apple juice in this survey given the person is a child? Round to the nearest hundredth. All right, pause the video now and see if you can figure out this relative frequency. All right, this time, I only care about the children, right? Given that the person is a child, I want to know the relative frequency of them liking apple juice. Okay, so in this case, I only care about this column. All right, when I add those together, 28 plus 19, I get 47. So there were 47 total children. And of those 47, 19 liked apple juice. So that's going to be 19 divided by 47. Again, just to make sure you understand where that came from. I just want the number of children that preferred apple juice divided by the total number of children. 19 divided by 47, Bring our calculator back up. Come on, there we go. And that's 0.40. So 40% of children preferred apple juice, right? That's how we interpret that. 40% of children preferred apple juice, which means probably 60% of children preferred orange juice. Keep in mind, right, 74% of adults preferred orange juice. Only 60% of the children must have preferred orange juice. So you can see, right, we can already see some associations here. The kids seem a little more evenly split between orange juice and apple juice. The adults vastly prefer the orange juice, right, by basically 75% to 25%. All right, so let's wrap this up. Right, as we've seen before, categorical data is very different than numerical data, right? It's very different than when you're doing mean, median, modes, all of that kind of stuff, right? Categorical data is basically, you go out, you do a survey, you ask some people, you observe people, whatever, and you throw them in categories. And the idea of what we were looking at today is these frequencies and relative frequencies, and to see how likely it is that somebody that falls into one category might also then fall into another category. In the next lesson, we'll look at that way more formally to see if we can draw some conclusions about whether one category or being in one category then is associated with being in another category. For now, I just want to thank you for joining me for another NGen Math 8 lesson by eMath Instruction. My name is Kirk Weiler, and until I see you again, keep thinking and keep solving problems.